So this tutorial will be explaining the concept of trees in Python. So we are going to have a tree and then we are going to represent it with code in Python. The reason I'm doing this is because for many data structures like tree and graphs is quite difficult to understand. So I want to actually break it down by creating the visualization right here and actually writing the code, and then we are going to be doing something like BFS and DFS and printing the nodes in the tree, and then we see how clear it becomes from there. So the first thing I want to tell you is that this tree could be binary tree or could not be binary tree. For now, let's assume that we work with a binary tree, and let's go ahead to shove all this data into this tree. So let's start from G, and we start with G, and we have G goes here, so G becomes the root of the tree, and we want to impute C. Where does C go? C is less than G, so it's going to go to the left. So I'm going to put C right here, so this goes. So B is less than G, and also is less than C, so it's going to be exactly here. And we go to A. A is less than G, is less than C, is less than B. So A is going to be here. So we're going to insert E. E comes to, is less than G, but is greater than C. So it comes here. And we go to D. D is less than G, so it goes this direction. E is greater than C, it goes this direction. It's less than E, it goes this direction. So what it means is that items that are less than the root goes to the left, but greater than the root goes to the right. So I hope you understand it. And let's go to F. F is less than G, is greater than C, and is greater than E, so F goes here. So I hope by now you can build up the remaining part of the tree. So I'm going to simply complete it for you. So I goes to I is greater than G because GHI. So I goes here, and H, H is less than I, so H goes here. J is less than I, so J goes here. K is greater than J, so it goes here. All right, so we build up the tree. So the question now is, how do we build up this same tree in Python? Well, this is where we need to actually understand the concept of data structures. For you to create a data structure, you need a different type. So we are going to create a type that we are going to call node, and a node is going to have left child, right child, and data. So for instance, if you have a node, for instance, we have a node like this. We just grab a green pen or blue pen. So if you have a node like this and it has 1, 2, and 3, you have this data here. Let's call it whatever, I'll call it A. And here can be null, or it can be something else, or it can be anything. So this is exactly what a tree looks like. So this can be anything. It can be a tree as well. It can also be anything, maybe null. So we need to create a data structure that has these three attributes. So let's go ahead to write the code right now in Python. So I'm going to create a class. I'm going to call it node. And we need a constructor that takes three items. So I'm going to say def. The constructor is init. That's the syntax for the constructor. And we need to give it the data for that node, for the root node. Okay. All right, so we are going to provide the left, the right, and the data. Or we are going to specify the left, the right, and the data. In this case, we only have the data, so we're going to set the left and the right both to null. So I'm going to say self.left is equal to none. And sorry, I don't think I need a comma here. Self.right is equal to none. And self.data is equal to data. So this is basically how to represent just do this. Basically how to represent a tree in Python. So basically these are pointers to the left subtree, the right subtree, because a node can actually have several trees to the left or to the right. Okay, this is fine. So how do we then insert item? Actually, how do we build up this tree? How do we do what we did just now in code? So we do need another method called insert that takes data. So we need another method. I'm going to call it insert, def insert. And this insert is going to take the data to insert. So it's going to take data to insert. Now, since we are talking of a binary tree, we now need to do a bit of logic here. So once you have this data to insert, you want to check first if there's data in the root, right? So you want to check if there's already existing data. If there's no data in the root, then you're simply going to set the root node here. So I'm going to first say if self.data, if self.data is none, so we are going to simply set the root of the tree by saying if self.data is equal to none, we set the root of the tree by saying self.data is equal to data. However, if there is something there, so in this case, if we have checked in the root node and there is something there, then we're going to check the left and the right, okay? So assuming we have this G here, we inserted G, okay, and we want to insert C. What do? We are going to check, compare this C with G and see if it is greater or smaller. If it's smaller than what is in G, we simply put it as a left child. If it's greater than what is in G, then we put it in the right child of the tree. So let's just do that check at this point. So I'm going to say else. So this else means that there is data in the root, and we simply have to check the left and the right subtree. So I'm going to say if data, the data we want to insert is less than self.data. So if it's less, it means that we're going to insert it. If it's less, take note, if this data we want to insert is less than whatever it is, we're going to put it to the left. So we are going to do one more if statement. If self.left is none, then we are going to set this data to be the left child. So I'm going to say self.left is equal to node and specify the data. Okay, so what happened here is that once we check and there is no item on the left child, we simply set that left to the node. However, if we want to check and there is some item here, we can check again. Is there something here and here? If we continue to check, what does that tell you? You need to use recursion. So you don't continue to check. So once it's null, we insert it, but if it's not null, there's something there. So else, there's something there, we are going to recursively insert. So I'm going to say self.left.insert and specify the data. So it's going to recursively continue to check the left subtree. In this case, it's going to be this. It's going to recursively insert here. So it's going to, once it has this, recursion is going to take care of exploring the remaining nodes that are children or descendants of C. Okay, so I'm going to say elif data is greater than self.data. In this case, now we want to insert to the right, because it's greater now. And we are going to do exactly the same thing with it. If self.right is none, okay, we are going to say self.right is equal to the new node we have using the data, and then we say else. It means that there's something in the right tree. We are going to then recursively insert the new node. So I'm going to say self.right.insert and specify the data we want to insert. Okay. All right, so this is how to build up this tree, and I think everything should be fine at this time. I'm going to now create a new tree and insert all these items into this spot. So I'm going to start with creating a root node. root is equal to node. We are going to start by inserting G. All right. So these are our root nodes. So these are characters. So I'm going to enclose in single quotes. It's going to be G. And the next thing we want to do is root dot insert, and we insert C, and so on and so forth. So let me just kind of copy and paste and then change up our things a little bit. So I'm going to copy. So we build up our tree at this point. So this is exactly what to do to build a tree in Python, right? So I hope this is clear. Now the next thing we are going to be talking about in the next class, we are going to be seeing how we can do breadth first search and actually print out the items of this tree in a breadth first manner. That is, we are going to print this in a breadth first manner. And in the next following tutorial, we're going to now do depth first. So we're going to do this. We're going to do this, and so on. So for now, I'd like to thank you for viewing. Please remember to subscribe to my channel and leave me a comment if this has been informative for you. I remain Kindson the Genius, and I'm always there for you.